In this session, we will perform exploratory data analysis, commonly known as EDA, on a real-world telecom churn dataset. EDA is the most important step before any machine learning model because it helps us understand the data's structure, behavior, patterns, and hidden insights. Let us begin by importing the required Python libraries. We first import Pandas, which is used for data manipulation and analysis using data frames. Next, we import NumPy, which supports numerical and mathematical operations. Then we import Matplotlib, which helps us create basic plots and charts. Finally, we import Seaborn, a statistical visualization library built on top of Matplotlib. The command sns.set of style is equal to white grid sets a clean background style for all our plots, making them easier to interpret in a presentation or report. Now, we load the dataset using read_csv function from Pandas. Here, we are loading a telecom churn dataset which contains customer usage details and whether the customer has churned or not. The df.headoff command displays the first 5 rows of the dataset. This helps us visually verify that the data has loaded correctly and gives us a first impression of column names, values, and data types. The df.shapeof command tells us the size of the dataset. It shows that we have 3,333 rows, meaning 3,333 customers, and 21 columns, which means 21 variables describing customer behavior or 21 features. The df.info_of function provides a detailed structural overview of the dataset. It tells us the column name, data types such as integer, float, or object, and whether there are missing values. We can also see memory usage, which is useful when working with large data sets. Using df of international plan.unicof, we check the distinct values in the international plan column. This confirms that the variable is categorical with values such as yes and no. This step is crucial before encoding categorical variable for machine learning. Encoding is converting yes and no into numbers. The qualitative data is converted into quantitative. Feature engineering is the heart of EDA. Here, we transform raw data into meaningful indicators that capture customer behavior more effectively. We create a new feature called total usage minutes by adding total day, evening, night, and international minutes. This gives a single consolidated metric representing overall customer usage intensity. Next, we calculate total calls by summing up day calls, evening, night, and international calls. This feature captures communication frequency, which often influences churn behavior. We now calculate average call duration by dividing total usage minutes by total calls. This represents the customer's calling style, whether they make many short calls or fewer long calls. We also handle division by zero errors by replacing infinite values with zero. The feature high service interaction flags customers who contacted customer service more than 4 times. Frequent service calls often indicate dissatisfaction and are strong churn predictors. The international usage flag marks customers who actually use international services. This helps distinguish between customers who merely have access and those who actively use it. The international plan mismatch feature identifies customers who do not have an international plan but still make international calls. Such mismatches can lead to unexpected charges and dissatisfaction. We compute usage per month by dividing total usage minutes by account length. This normalization usage across customers who have been with the company for different durations. Finally, we display the newly created feature to verify correctness and understand their distribution. We filter the dataset to include only churned customers using mean of. Using mean of, we compute average values for numerical features. This helps us understand the typical behavior of customers who leave the service. Here, we analyze loyal customers who do not have an international plan. We examine their international call minutes to check whether such behavior exists. The result, the result being NAN, not a number, indicates no such cases in the dataset. Using group by of, we compare average total day minutes between churned and non-churned customers. We also create a crosstab between international plan and churn status. This normalized table shows churn propositions and highlights strong relationships. We plot a histogram for total day minutes. This shows the distribution shape, spread, and central tendency. In Python, a kernel density estimation curve is a smooth, continuous line used to visualize the probability density function (PDF) of a continuous random variable based on a finite set of data samples. The KDE curve helps us see whether the distribution is symmetric or skewed. We visualize churn distribution using a count plot. This reveals class imbalance, where non-churned customers significantly outnumber churned ones. We also plot the distribution of international plan subscriptions. Using a pair plot, we analyze relationship between total day, evening, and international minutes. Diagonal plots show distributions, while off-diagonal plots show correlation and scatter patterns. We use box plots and violin plots to compare total day minutes across churn categories. These plots clearly show that churned customers tend to have higher usage variability. We compute a correlation matrix to measure linear relationship between numerical variables. Linear relationship means a vertical line. The heat map visually highlights strong correlations such as minutes and charges and their relationship with churn. Finally, we run describe of to generate summary statistics such as mean, standard deviation, and quartiles. We check for missing values using isNullOf.SumOf and duplicates using duplicatedof.SumOf. These checks confirm that the dataset is clean and ready for machine learning. Thank you.